So here in also see, we are doing the revision for oscillations and waves. Okay, and we will do some important questions also. So here again on the English, once you are done with the English examination, I will be taking again revision. Okay, revision of all the lessons. And you also should go through if you have any doubts in any lesson. You have to mark it in the textbook or in the notebook. Then you can ask me in the class. Okay, in the revision classes, because you won't be coming to the school, so you can take online. Anyways, the link will remain same, and I will tell the timing in the groups. Okay. Now, see, for oscillations in the oscillations chapter, we don't have many derivations. There are only two derivations are there. That is time period of a spring and time period of a simple pendulum. Only two derivations will come, and one is energy stored in a simple harmonic wave or in simple harmonic oscillator. Nu is equal to 1 by t. This is the frequency. T is the time period. Omega here is angular frequency, that is equal to 2 pi nu or 2 pi by t. And here we have equation of displacement. Equation of displacement, if you are taking, you can start either with a sin omega t or you can start with a cos omega t. Either you can start with a sin omega t or you can start with a cos omega t. So here velocity equal to how much? A omega cos omega t. And acceleration will become minus a omega squared sin omega t. Okay. So that we can write as minus omega square x. Whether you start with sin or cos, it's same. Okay. The value of velocity acceleration will not change, but it depends upon what displacement he has started with in the numerical. Now, same way, if you are starting with cos, it will become minus a omega sin omega t, and here it will become minus a omega square cos omega t or minus omega square x. Here, omega is what? Angular frequency or omega equal to under root of k by m. This is for the spring. Kinetic energy formula is half mv square. But here I have taken velocity is this value. Okay, this value. Same way, potential energy I have used this formula, A cos omega t. See, half mv square, wherever there is v, we have substituted this value. Same way, in the place of displacement, we have used this value in the textbook. That is equal to half kx square. Now, time period of a spring, t 2 pi under root of m by k. Time period of a simple pendulum, t is equal to 2 pi under root of L by g. And kinetic theory, in kinetic, these are the formulas which are for oscillations. And next for kinetic energy, next we have Boyle's law. In Boyle's law, he says that at constant temperature, pressure is inversely proportional to volume. P1 V1 equal to P2 V2 or PV is equal to constant. In Charles' law, P is proportional to T or volume in here when volume is constant or P by T is constant. Here we have P1 by T1 is equal to P2 by T2. And Gay-Lussac's law, V is proportional to T when pressure is equal to constant or V by T equal to constant. V1 by T1 equal to V2 by T2. This is the way we use in the numerical. These formulas we use in numericals. They will give three values. You need to find out the fourth value. Clear? Now, any doubts in this? Any doubts in this? Okay, very good. We'll go ahead now with the next one. The next one is Dalton's law. Dalton's law of partial pressure. It tells about P equal to P1 plus P2 plus P3. This is about, suppose if you are non-reacting gases. And Graham's law of diffusion. Diffusion means motion of particles from high concentration to low concentration, like someone wearing a perfume. That's the best example. So P is equal to P. So here we have P1. P is equal to P1 plus P2 plus P3. Graham's law of diffusion, V is equal to under root of 1 by rho, or V2 by V1 is equal to rho 1 by rho 2. Density is mass by volume. Avogadro's law is what? With P and T is constant, V is proportional to M. Volume is directly proportional to the number of moles. Okay, so next is ideal gas equation, PV is equal to mu RT, where mu is number of moles and R is universal gas constant. Okay, so mu is equal to N by N0. Please tell me if the video quality is poor, please let me know. Sorry. If any problem is there, yeah, it's okay, right?
Yes, sir, it's okay, sir.
Hmm.
Yes, sir, it's okay.
Okay. Then, okay, so here ideal gas equation PV is equal to mu RT, R is equal to 8.314 joule per mole per Kelvin. Universal gas, this is universal gas constant, and is mu is number of moles. V is equal to N by N0, which is equal to small m by capital M. M is the mass of the substance and capital M is the atomic mass or molecular mass. N0 is the Avogadro number, that is equal to 6.023 into 10 to the power of 23. N is the voice is going high and low. This fluctuating in the voice. Uh, Let me see. One second, then I will stop for a while. See here. Ideal gas equation PV is equal to mu RT. R is a universal gas constant and mu is number of moles and N is capital N by small n. What happened? Okay. Okay. If you are not able to hear, let me know. Okay. In the chat box. Okay. So N by N0 equal to small m by capital M. Small m is the mass of the substance. Capital M is the molecular mass. N0 is Avogadro number and capital N is number of atoms. Okay. Capital N is number of atoms. Okay. So now, so here, so here we have PV is equal to KBNT or KB, that is Boltzmann constant, 1.38 into uh, okay. Oh, okay. Now, okay, here we have pressure exerted by the gases on the walls of the container. The derivation is 1 by 3 mn c square bar and mn v square bar. And next is kinetic interpretation of temperature. K is proportional to T. Next is law of equivalence of energies. The formula is half mvx square plus half mvy square plus half mvz square. Okay. And ER is equal to, and this is for rotational, this is for translation. In translation, there are 3 degrees of freedom, and in rotational, there are 2 degrees of freedom. Okay. That is clockwise and anti-clockwise. Okay. Now, I'll write for the third one. Is it clear? Did you write down this one? Yes, sir.
Yes, sir.
Yes, sir.
Okay. Going ahead now. Going ahead. Next one. So vibrational EV is equal to what? 1 by 2 m into dy by dt whole square plus half ky square. Okay. So here, the next one is what after that? This is for vibrational modes. Okay. Next is for specific heat capacity. Specific heat capacity. In specific heat capacity, as you know, there will be three. Okay. Monoatomic. That is the atom is itself a molecule like helium, neon, argon, krypton, something. So Cp is equal to, first we'll calculate Cp and Cv. Okay. Cv is equal to 3 by 2 R and Cp equal to 5 by 2 R. You are using the formula Cp minus Cv is equal to R. Okay. So gamma value is equal to how much for monoatomic? Is equal to 5 by 3. Second one, we have diatomic. In diatomic, we have two. The first one is rigid. In rigid diatomic, that is what? In rigid diatomic, uh, that is Cp, that is Cp and Cv. Cp is equal to 7 by 2 R. Cv equal to 5 by 2 R. Gamma equal to 7 by 5. The second one is non-rigid. Non-rigid, Cp is equal to Cp equal to 7 by 2, so it's 9 by 2, so 9 by 2 R, and Cv is equal to 7 by 2 R, and gamma value is equal to how much? 9 by 7. Gamma is 9 by 7. Next, third one is polyatomic. In polyatomic, gamma equal to how much? 4 plus F divided by 3 plus F. This is, F is what? Vibrational modes. F is vibrational modes, vibrational degrees of freedom or vibrational modes. Clear? Next one, and next one is what? Specific heat capacity of specific heat capacity of solids. Specific heat capacity of solids. So here we have the formula. C is equal to, so C is equal to 3 times of R. Okay. And here we are using the formula delta Q is equal to delta U plus P delta V. But here delta V value is equal to 0 in solids. Okay. So we have 3, C is equal to 3R. Next one is what? Specific heat capacity of water. Specific heat capacity of water. Specific heat capacity of water. The formula here is what? C is equal to, again, C is equal to 9R. Okay. Last one is mean free path. Mean free path. Mean free path formula is what? Tau is equal to, L is equal to, there are two formulas. Tau is equal to time. That is the time between two successive collisions, n pi v, average velocity, and d. Okay. D is the diameter of the atom. Okay. And L is what? L is equal to 1 by under root of 2 n pi d square. This is the formula. So this is for the kinetic theory. If you have any doubt, ask me in this one. If you have any doubt in this, please do ask me.
Sir, you are not visible.
Why is it not visible? What happened?
Sir, actually, I thought your video got stuck.
Yeah, okay, okay. No, no. Now, shall we go with the next lesson? If you're done with this, if you have any doubt, ask me, please.
Yes,
Please
sir,
do
we
ask me.
can move. Yes, sir,
Go
we
on.
can move.
Okay, then I'm going ahead now. Okay. So I'll go with the next lesson. Okay. So here in this case, we will go with the last chapter, that is waves. Okay. And then we will discuss some important questions also. Okay. Waves. In waves, we will discuss waves. Here the formula, the first formula, equation of a wave. Equation of a wave. So here we have y of x comma t is equal to a sine kx plus omega t plus phi here. Okay. A is amplitude, and k is equal to 2 pi by lambda, that is propagation constant. And omega is 2 pi nu, or 2 pi by t, that is angular frequency, and phi is phase. Phi is the phase, okay? Or wave angular wave number also. Absolute value, yeah, absolute average value, not absolute. Not absolute, average value. That is okay. So this is angular wave number also we can say it is measured in radians per meter. Okay, angular wave number as I told you in the previous class also. So we have second one nu is equal to 1 by t, which is equal to we can write omega by, and also we have omega equal to we can write 2 pi nu, or we can also write 2 pi by t. These are the two formulas. The speed of the wave, third one, the speed of the wave is equal to v is equal to, we have v is equal to nu lambda, okay, or we can also write implies v is equal to lambda by t. Fourth one, we can write here v is equal to under root of t by nu. Fifth one, we have for v, this is for a wire, okay, for a, this is for string or a wire, okay, string or wire. V is equal to under root of b by rho or y by rho or p by rho. This is for gases. Sixth one, Laplace correction v is equal to under root of gamma p by rho. This is Laplace. Laplace is corrected. Laplace correction. Laplace correction. The value of gamma equal to 7 by 5. Okay. So 7 by. Next is what? Transmission reflection of a wave. Uh, Superposition principle. Seventh one. Superposition principle. In superposition principle, we say y1 is equal to y1 of x comma t equal to a sine kx minus omega t, and y2 x comma t equal to a sine kx minus omega t plus 5. Two equations we have taken. And the final equation y is equal to what? y1 plus y2. So y is equal to y of x comma t equal to 2a sine kx minus omega t. Next is what? Reflection of a wave. Reflection of a wave. So here we have y of transmission is x comma t equal to a sine kx minus omega t, and for reflected wave x comma t equal to a sine minus a sine kx minus omega t. Okay, transmitted and reflected one. Next one is standing wave or stationary wave. Stationary wave. Stationary wave or standing wave. So in standing wave, the first one is what? Uh, First harmonic. First harmonic fundamental frequency. Fundamental frequency of first harmonic. Sorry. Fundamental frequency or first harmonic. Okay. Fundamental frequency of first harmonic. Okay. In that, we have the first formula V is equal to mu is equal to V by 2L. Mu 0 equal to V by 2L. Second one is second harmonic or first overtone. Second harmonic or first overtone. Mu 1 is equal to 2 times of mu 0. Third is third harmonic or second overtone. Sorry, three times of mu zero. Okay. This is the standing wave. If you need please ask me. Next, we have this is the same for standing wave or open pipe also. For open pipe also, same formula. Open pipe also, same formula for waves. Once done, please let me know. Please do ask me if you have any doubts. This all we have done in the previous classes. Done, sir. Can I go ahead now?
Done, sir.
Okay. We'll go ahead now. The next one. That is 10th one, closed pipe. In closed pipe, we have first harmonic fundamental frequency. Fundamental frequency at first harmonic. That is what nu zero is equal to V by 2L, 4L. V second harmonic, our first roboto. Nu one is equal to 3 times of nu zero. Third one, third harmonic or 5 times of mu zero. Okay, next is beat phenomena. Beats n is equal to nu 2 minus nu 1. Difference. This is not minus, this is the difference. Okay, whatever whoever is bigger, we write first. And here we have when we wax, waxing the tuning fork. Waxing tuning fork, tuning fork, frequency decreases. Frequency decreases. And also keep this in the mind. N should be every time less than or equal to 10. Then only pitch is heard. Condition. Second one is filing. Filing tuning fork. Filing tuning fork. Frequency increases. Okay. That is for the Beats phenomena. Last one is what? Doppler effect. So the last one is Doppler effect. We have, I told you there are 8 cases in Doppler effect. In Doppler effect, what is the formula here? Nu equal to or nu dash equal to V plus or minus B by V plus or minus A by nu. There are total 8 cases, as I discussed before. Depends on the situation. So A is velocity of speed of observer. This is A is for observer. D is the velocity of source. Source or observer? V by V minus A. Source is so sorry. This is source. The first one is source, and the second one is observer. Okay. Nu is the frequency of sound. Frequency V by V minus A into nu. Yeah, that's it. Okay, now we will discuss some important questions now. Okay, chapter wise we will discuss some questions now. Okay. Yeah. First in waves, I'll discuss important questions. The first one is speed of sound and Laplace correction. This is the important derivation. Okay. Second one in this one is open pipe, closed pipe, stationary waves. Okay. Open pipe, closed pipe, stationary waves. Next we have open pipe, closed pipe. Fourth is stationary waves, and fifth one is beats phenomena. There will be numerical in beats. There will be numerical, and last one is Doppler's effect. Doppler's effect also same. There will be a numerical on this. Coming to the last previous lesson, that is oscillations chapter. Oscillations chapter. What are the important questions? Number one, or there can be one more question here. I can add one more question here. Seventh one. Okay, seventh one I can add here.